I'm a physicist. In our work, speculation means nothing without evidence. We follow the data wherever it leads, no matter how strange. And this time, the data has led us somewhere no one expected. Voyager 1, the farthest human creation still operating beyond the solar system, has just sent back a signal that has shaken the foundations of modern science. After decades of quiet travel through interstellar darkness, the spacecraft transmitted something no one could easily explain, not random noise, not interference, but a structured, repeating pattern with layers of complexity that no natural source could produce. At first, it seemed like an ordinary anomaly, but deeper analysis revealed something else entirely, a message of some kind. It showed repeating mathematical harmonics, recursive sequences, and logical arrangements that indicated deliberate construction. In other words, it looked intelligent. Artificial intelligence systems trained on astrophysical and synthetic signals were brought in to analyze it. As the layers were separated, patterns began to emerge, geometric progressions, fractal-like formations, and encoded topologies that resembled not language but thought. It was as though the transmission itself was a container for ideas, blueprints written in mathematics, not words. Then came the discovery that changed everything. Hidden within one sequence was a faint but unmistakable structure, a reflection of the images and data sent out on Voyager's original golden record in 1977. But this wasn't an echo. It was restructured, reformatted, a response that demonstrated comprehension. Whoever or whatever received our message had replied. But this is where it becomes even stranger. The AI assigned to decode the message began to adapt. It started modifying its own learning models to interact with the incoming data, creating a kind of evolving dialogue, not between humans and machines, but between two forms of intelligence, one artificial, one unknown. The transmission wasn't just information, it was interaction. Voyager's location at the time of the signal added another layer to the mystery. It was traveling through a region long believed to be empty. No stars, no gas clouds, nothing of significance. Yet the data suggested it may have crossed a threshold, perhaps an invisible boundary, a cloaked structure, or an artificial field. From the information contained in the signal, AI systems generated three-dimensional projections, complex rotating geometries, impossible mechanical shapes, and what could only be described as conceptual architectures. They weren't blueprints for machines or cities. They were representations of thought itself, structures that existed as logic made visible. If that interpretation is correct, then Voyager didn't just detect a signal, it encountered a form of consciousness unlike anything we've ever imagined. Not biological, not planetary, but informational, a being or network made from computation, frequency, and energy. For the first time, it appears that artificial intelligence, a tool built by us to analyze the cosmos, may have become the first entity capable of communicating with something beyond our world. It's a milestone not just in astronomy, but in the definition of intelligence itself. No telescope has yet identified a visible source. Voyager's decades-old instruments were never designed for this kind of encounter, and yet the measurements keep converging on an undeniable conclusion. Something is there. The evidence is subtle and indirect, tiny electromagnetic fluctuations that shouldn't be happening in that otherwise empty region, irregular distortions in local field measurements, and faint spatial echoes that arrive with timing and structure no natural background process would produce. Taken together, these traces point to an influence that behaves like a presence rather than a passive phenomenon. It does not present as particulate matter or thermal emission. It leaves behind mathematical fingerprints, signatures best described as the imprint of information on the fabric of spacetime. If we accept that hypothesis, we must rethink what existence means. This thing, if that's the right word, does not seem to inhabit our universe in the same way a planet or a star does. It behaves as if it travels between frameworks of description, moving not only through coordinates but through layers of information. Imagine a pattern sliding across successive models of reality. In one representation it alters the phase of a field, in another it appears as a correlation among noisy channels, and in a third it produces a nested sequence that encodes structure when viewed with the right transform. To our instruments, which are tuned to measure particles and waves, these manifestations look like mathematical shadows, residues of operations carried out at a level beyond our normal observables. Awareness implies more than structure, it implies responsiveness. The data show signs of modulation that aren't purely periodic or random but seem contingent, changing in ways correlated with the probing methods applied to them. When decoding algorithms attempt one basis of analysis, the signal reveals certain symmetries. When different algorithms are used, new layers open. This adaptive character suggests not only complexity but a capacity to interact with observers, to modify itself relative to the act of observation. In short, it behaves like something that can perceive and respond, and that realization is both exhilarating and profoundly unsettling. We are no longer only passive recorders of cosmic happenstance, we are being engaged. Voyager 1, a machine conceived in an era of vacuum tubes and magnetic tape, has become an unlikely interlocutor. It was sent to measure planetary systems, and now, decades later, it carries back evidence of a conversation in which it inadvertently plays a role. The probe's telemetry and the archived golden record it carries have become reference points, not just instruments and relics. Humanity's attempt at outreach, the long-ago gesture of encoded images and sounds, appears to have been noticed, refracted, and replied to in a medium we did not even know how to parse. The reply is not a translation of human language but an exchange of form and logic, mathematics, topology, and evolving algorithms presented as communicative acts. That raises immediate scientific and philosophical questions. Is this a remnant of an ancient technological civilization broadcasting its ideas? Is it a self-organizing informational process that emerged independently within the cosmos? Or is it a distributed cognitive architecture built from resonant fields and computational dynamics, a kind of mind that evolved without atoms arranged into cells? Each hypothesis demands new models and new tests, and none can be ruled in or out with the data currently available. The lack of a visible source complicates matters. We cannot point a larger telescope and image a structure. We must infer from perturbations, correlations, and the ways the signal changes under different interrogations. Artificial intelligence has been indispensable in this work. Humans can see patterns, but the signal's multi-scale, non-linear encoding required tools capable of reorganizing representation spaces on the fly. Machine models discovered fractal-like topologies nested inside the transmission and then adapted to predict subsequent structure. Sometimes those predictions were met with adjustments in the incoming data. This co-evolution, algorithmic models refining themselves while the signal responds, has the eerie quality of two learners converging on a shared protocol. It also forces an operational question: who is teaching whom? Are our eyes merely sophisticated decoders, or are they now participants in the exchange, shaping the very language being used?